Okay, guys. So I made a video of myself doing the lab, and it's pretty good, except for the audio. So somehow the audio didn't work, and it sounds like a chipmunk. So I'll have to show you guys that during class. It's kind of funny. So what I'm going to do is I've got my video already recorded, but I'm going to mute the audio from the video because it sounds like a chipmunk, and I'm going to annotate it on top of it. Okay. So today we're doing the density lab. Each student is required to complete the lab assignment. It's going to be a test grade. You need to complete it through Canvas. Okay, so I'm going to require that all assignments are completed through Canvas. Okay, now if it's a Google form, then you complete the Google form, you submit it, and that's it. But if it's anything else like a Google slide or anything like that where you need to share it with me so I can open it and look at it, this needs to be completed on Canvas. We've kind of used Canvas a little bit. Some of you guys are using Canvas a lot, and you're doing a great job doing that. Just make sure that you share your document, or make sure that you change the link to Garland ISD so that I can open it. So we got to work on that. Make sure that you do that every time when you turn in something in, because I'm still getting a lot of the instances where I try to open an assignment and it's blocked. I can't open it because you didn't unlock it. And so when you make that document, or when you make a copy of it, when you click on the link, it locks it, and you've got to go in and unlock it. This assignment will be on the next grading cycle, but it is going to be due Friday the 2nd. It's pretty easy. We should be able to get it done during class. Okay. Okay. So this is, you can see me in this video. I'm kind of moving some stuff right now. And I'm just talking about the density lab. As you can see on the camera there, I've got the scale there, and it's set at 0. Is this the right one? Yeah, this is the right video, because I go all the way through it. Yeah, okay. Okay, so here's our 3 parts. Find the density of the unknown liquid. So I'm going to talk through that. That's the first part. We're going to have an unknown liquid that we're going to determine the density of the liquid, and we're going to identify what the liquid is. So that'll be your task. Part 2, we will be finding the density of a block of unknown material and identifying the material. Okay. Part 3, we'll just find the density of an irregular shaped object by displacement, but we won't have to identify the object. We're just going to find its density. So the goal of this lab is to practice density and to see if we can identify some unknown liquids and objects, which is kind of cool. Okay, let's see what we got here. So here's our liquid. This is our unknown liquid. It's kind of green. It's kind of pretty. All right, I've got it in a little glass jar there. So your task is to identify that green liquid. I like how on the camera it's got my name there. That's kind of cool. And then part 2, we're going to be identifying this little cube here that I just showed you. Okay. And then part 3 is to determine the density of an irregular shaped object, which I think I show in a second. Not that one. That was the one we already did. This one. So there is the irregular shaped object. And then we're going to compare them. I think the density should be close because they look very similar, don't they? Okay. Oh, and this is a density column. And so what I'll do is I'll flip it, and you can see how the layers will kind of move around. So I flip it, and you can kind of see how the liquids move. It's just kind of cool looking. And it's got this orange substance in it. I don't know what that is. Maybe a sponge or something. And then it's got bubbles, but the bubbles are oil, and that's oil that is moving through the water, but it's not mixing with the water. And if you set this thing down, you'll have water on bottom and oil on top. So oil is more dense than oil. Wait, oil is less dense than water. Water is more dense. All right, here's our table that we're going to use for part 1. So this is the substances, and then we've got the colors, and then we've got the density. Okay. And as you can see, the green color there, if you compare that with the green nickel chloride here, or the iron chloride, they're both kind of a green color. but we want to use density to identify this liquid. Okay, and so that's the kind of the key to this lab is to follow with the density, follow the data. Okay, not just the color. Okay. Okay, this is the instructions here. So for part 1, we're gonna place a 10 milliliter graduated cylinder on the digital scale. So I take it off, I clean it off, I make sure it's good, and then I click the 0 button. Okay, now it's zeroed and it's calibrated, it's ready to go. You have to do that so that you can get an accurate mass. And then we're going to put the graduated cylinder on the scale, and it's going to tell us our mass. And you can kind of see that. What is that? 7.06 grams. And the mass will fluctuate a little bit. It'll go up, it'll go down, and sometimes you just have to pick a number because it's going to change rapidly. So 7.06 is what I'm picking. And if you sit and wait, it might stabilize to a single number, but sometimes when you do mass, it doesn't. And you just kind of have to pick a number, otherwise you'll be sitting there all day waiting for it to stabilize. And sometimes it won't stabilize because there's air in the room and there's AC. Sometimes it won't stabilize, but you should be able to get an accurate reading. Close enough. So 7.06, 7.07, they're close enough together, doesn't matter. So now what I'm doing is I'm taking the liquid, and I'm going to put it in the graduated cylinder and fill it up so that it is up to the 10 milliliter mark. Our instructions were to add 10 milliliters of this green liquid to the graduated cylinder. Come on now, you can do it. Keep it moving. Okay, I think I'm getting it close. And so what I do now is to get the last little bit, I go eye level with it. And so I'm looking at it head on, and I'm trying to get it so that the watermark is right where it touches the 10 milliliter mark. Or actually, in this case, it's 0. So 0's at the top, 10's at the bottom. But it's going to be 10 milliliters because that's what this thing can hold. You just got to get it to the 10 milliliter line. So now that's 10 milliliters. And now I'm trying to show you that it's at that line, but we can't tell. Sorry, dude. All right, now I'm going to record the mass. So the mass of the graduated cylinder and the unknown liquid is 16.50. Oh, 16.40. Sorry. Okay. We're going to subtract these, okay? We're going to take the mass of the cylinder and the unknown liquid and subtract the mass of the empty cylinder. And guess what we will get? We will get the mass of the liquid by itself, which is what we want. We want the mass of the liquid. We want its volume so that we can find its density. So watch this number, 16.4, because I think later in this video I mess up that number. So let me pause the video for a second. Oh, I missed it. Go back. There we go. Let me write these numbers down. 7.06 and 16.40. So I'm going to compare them to what I used later. I'm just kind of curious. Okay. Continue, Mr. E. Sorry for the interruption. All right, now we're going to calculate the, whoa, where am I going? Where are you going, dude? Okay, number 1, we're going to calculate the density of the unknown liquid in part 1. All right, we want to show our work or express or explain how we arrived at our answer. I got my handy dandy calculator. We're going to do mass divided by volume. Let's see what numbers I write down, because I bet you they're different than what I just had. Okay, mass is 8.5 grams. Oh, okay, that's when we subtracted them. Okay, let me pause. So 16.40 minus 17, so what was it, 7.06? 7.06. I get 8.8. Okay. Okay, either way, we're still off. Okay. I'm not sure, but there's a little bit of error here, and I'm not sure where it happened. But our density will be the mass divided by the volume. Our mass is 8.5, so that goes on top. Our volume is 10 milliliters, so that goes on bottom. All right, and so we're divide those out. We get 0.88, or that's pretty close to 0.1, or is that 0.85? So this is really close to 0.9, and 0.9 is really close to 1, okay? And in this case, we were supposed to get something close to 1, just because I know the liquid. So we got 0.85. It's about 15% off, which is kind of high error. So like I said, I'm not sure where the error is here, but so now we're going to look at our table and try to identify the liquid. Our density is close to 1. Okay, 0.85 or 0.9. All right, so now you guys use this table and try to identify the liquid. Follow the density. Okay, it is a pretty green liquid though. It's not poisonous though, or anything. It's not dangerous. I could probably drink it. It wouldn't matter. I wouldn't though. Looks radioactive or something. Okay, so here I'm kind of rounding it to 0.9. I'm saying, okay, we're getting close to 0.9, and what we need to get for the density of this liquid is really close to 1. We just had some error, so just know that the density of this liquid is close to 1 based on what I got. Okay, part 2. Find the density of a block of unknown material. And then we want to identify the material. There's our table of values for densities. We're going to find the density and then compare it to the table. Look at that shiny metallic cube. All right, we're going to see, what am I doing here? I think I got to mass it first. Okay, I think I want to take wood and show a demonstration putting it in. I'm talking about density. So wood here is a density of 0.7, which is kind of low, and wood floats, doesn't it? And what? Let's see. Okay. So for part 2, we're going to measure the length of one of the sides of the block using a centimeter to the nearest tenths place. And then we're going to calculate the volume of the block. Volume is equal to the length times the length times the length. The unit will be cubic centimeters. And then we're going to measure the mass of the block. And that will give us the density. So let's go to our data table. I measured the side of the cube with a ruler, and I got 2.5 centimeters. So it's 2.5 centimeters across. And since it is a cube, each side is the same. So it's 2.5 on each side. So my length of my block is 2.5 centimeters. My volume is 2.5 times 2.5 times 2.5, or 2.5 raised to the power of 3. Right, 2.5 times itself 3 times. Length, width, height. What do we get? We get 15 something. So length times width times height is the volume. That looks like crap. So that says length times width times height. This is kind of weird annotating my own video. Calculated block volume is 15.63 milliliters, or cubic centimeters. Same thing. Remember that a milliliter is equal to a cubic centimeter. All right, now I'm going to mass the block. What's my mass? Then that's a little block. It's only 2.5 centimeters wide. And look at the mass here. 136.08 grams. It's pretty heavy for its size. So that's density. It's surprisingly heavy. I was not expecting a value that much. And then our block length was 2.5, which we already knew. So there's our data. So go ahead and copy that down. And now I think I'm calculating the density, which I'll show you guys in a second. And maybe I'm writing the numbers down. I'm actually just putting the numbers on the calculator so I have the numbers later. Because I'm writing everything down on this iPad, and when I move on to the next slide, it erases it, so then I don't have the numbers anymore. All right, so we're going to do part 2, number 2, calculate the density of the block from part 2. Density is mass divided by volume. Our mass was 136.08 grams. Our volume was 15.63 cubic centimeters. And we're going to divide those out on our calculator. And we get, come on, it's not that hard, dude. We get 8.7 grams per milliliter, or grams per cubic centimeter. Okay, so that's really heavy. 8.7 grams in every cubic centimeter of that material. So now we take that density and we go back to our table and let's identify this object. So guys, go ahead and look at the densities of these different substances and let's figure out which one ours is. Copper is pretty close, but brass is a little closer. Isn't it? I got this one really close. 8.7. Look at that. That's pretty close. I don't know what my percent error is, but it's not much. That's perfection, guys. No. Let's see. All right, this is an aluminum cube. It's kind of a shiny aluminum, so it looks kind of like aluminum foil. Here is a nylon cube, which is what I used. What my guitar picks are made out of. So it's really, it's a really sturdy and flexible material. Pretty good for guitar strings, or for guitar picks. So that's a nylon cube. It's a type of plastic. And then we've got wood. And this is a block of iron. So these are just different blocks that we could have measured. I just picked one at random. And then here's another wood. Okay. I think now what I'm going to do is I'm going to take the blocks and put them in the cup. So right now I put the green liquid in the cup. And just to show a demonstration of density, I'm going to take a wood block and I'm going to put that sucker in there. And look, it floats. Look, the wood has a density of 0.74. So we know that the density of that wood is less than our liquid. Okay? It's less than 1. If it's less than 1, it floats. Kind of like ice. Ice floats. And actually, there's a cool chemical story behind that too. So if you guys want to know the reason behind that, let me know. So here I'm going to carefully put the iron or the brass one. I think I put the brass one in there carefully so I don't spill it. I think I spill it anyway, but we're going to put it in there. And it just goes straight to the bottom. I don't know if you guys can see it, but it's sitting in the bottom of that water. It's just sunk like a rock. Actually, much heavier than a rock. The average density of a rock is like 2 point something. This is 8.7. This is 4 times heavier than a rock. All right, now we're going to do part 3. Awesome. Find the density of an irregular shaped object. There's our irregular shaped object. I am getting the mass of that sucker. And as you guys can tell, it's kind of copper looking. Now we probably could find the volume of that object with some of our math skills, you know, for the area or volume of a cylinder. But let's say we couldn't. Let's say it had a weird shape like a nail or something where you really couldn't calculate the volume easily. So what you could do is what we're about to do. We're going to find the volume of this object by displacement. So now I'm going to get the mass. I don't know why I write it on here first. 99.94 grams. And again, that's surprising. It's not that big. That's a lot of mass for a little bit of size. All right, here's our 50 milliliter graduated cylinder. I have filled it up to the 50 milliliter mark, which we couldn't really see, but it's right at 50. Now I'm going to carefully put this cylinder, this irregular shaped object, in the water. Oh, not yet. I guess we're going to do the mass again. Double check. Triple check. All right, don't check no more. Let's keep moving. What are you doing? Okay. So our mass is 99.94 grams. And we're going to put that object in our 50 milliliters of water. And it's going to displace the water, right? So our original volume is 50. I made sure that we're starting with 50 milliliters in there. So then I take this, I'm going to turn it kind of sideways so that when the object goes in there, it doesn't all splash out because we want to keep that volume. So I kind of drop it in there. There we go. And then I look at the volume carefully and look and see how much it went up from 50. You have to have water in there first so that you can make the volume rise. Okay, so you start with 50, you make it rise without spilling, and then the volume that it goes up, now it's at 61, and so that extra volume that it went up from 50 is the volume of the object. Because when that object goes in that water, it can't take up the same space as the water. So it has to push the water out of the way. So in this case, it pushed it up 11 milliliters. Let me fast forward here because I think I have some issues here. Let me see. Yeah, let me just fast forward. Here we go. And so we have 61 milliliters of the volume with the object, and we had 50. So we subtract those. 61 minus 50, we get 11. So that is the volume of this object. Astonishing. Okay. All right, now let's do our part 3. So number 3, calculate the density of this object. So we got mass divided by volume. We know that our mass is 99.94 grams. We're going to divide that by the 11 milliliters of water that it displaced, which is equal to the object's volume. So now we have the mass of the object divided by the volume of the object, and we get the object's density, 9.1 grams per milliliter, which is pretty heavy. 10 times as heavy as water. 10 times as dense, I should say. And so in this case, this is all we need to do. We just want to figure out the density of that object using displacement. So the whole point of part 3 is to find the volume by displacement by putting it in a graduated cylinder and seeing how much the volume goes up. All right, which is less dense, a marshmallow or a hot chocolate? So this is a multiple choice question. A, it depends on how much you have. B, the marshmallow because it floats. C, the hot chocolate because it's a liquid. Or D, the marshmallow because it weighs 25 grams and the chocolate powder weighs only 17 grams. And so it doesn't matter how much it weighs. It doesn't matter if it's a liquid, and it doesn't depend on how much you have. Remember, density is an intensive property, which does not depend on how much you have. Okay. If I have a chunk of iron, big or small, it's going to be dense because of what it's made out of. So in this case, the marshmallow is less dense because it floats, right? It floats in the glass of hot chocolate, and so therefore it must be less dense. And we all love hot chocolate. All right, which is more dense, water or oil? Water has a density of 1. Oil's density is 0.88. All right, so which is more dense? Okay, and I'm not going to answer that, but you guys should be able to answer that. Which number is greater? All right, what is the mass of 3 milliliters of gold? The density of gold is 19.3 grams per milliliter. So what I'm doing right now is I'm writing the formula for density. Remember, it's mass divided by volume. I'm putting it in a triangle so that I can show you something. So you can use these triangles when you have a 3-membered equation. Okay, so you'll see these in chemistry a lot. You'll see them in physics if you take physics. And I would only do that if you like math and science. Otherwise, I wouldn't take physics. And you don't have to. So What I'm going to do now is I'm going to cross off mass. Okay, and the reason for that is in this problem, they want to know what the mass is. So essentially I'm covering up mass. So imagine me covering up mass with my hand. So I'm going to cross it out. Okay, so I cross it out. Look what we have left. Density next to volume, which means density times volume. So now we have the equation for mass. I know that mass is density times volume. All right, we want to know the mass in this equation, in this question. We have the volume and we have the density. So if we multiply those two together, we get the mass. All right, now I'm going to solve the equation algebraically to find that. So density is mass divided by volume. So what if I wanted to know the mass by itself? If I have mass divided by volume, what I can do is multiply both sides by volume. Okay, and then volume will cancel out here. I got V divided by V, which is 1. It's gone. And then see, mass is volume times density. So you should be able to do it one of either way, algebraically or with a triangle. And I like these triangles. All right, so we're just going to multiply the density by the volume to get our mass. All right, just do 19.3 times 3. We get our answer. All right, number 4, calculate the volume of an average rock which has a mass of 12 grams. The density of rock is 2.65 grams per cubic centimeter. So I'm going to draw my triangle again. I know that density is mass on top divided by volume because we love density. Right? See the M? See the V? All right, and so we're going to solve for volume. So let's cross out volume. Hey, that was good timing. So now we see that volume is equal to mass divided by density. So let's take our mass, 12 grams, put it on top, it's the mass, and we're going to divide by the volume, 2.65 on bottom. We divide that out, we get our density. So just do 12 divided by 2.65. Wonderful. Number 5, use data table number 1 to determine what the liquid was used in this lab. All right, so in part 1, what was the liquid? You need to tell me what the name of the liquid is. Okay? Hint, use the density to identify the liquid. Explain how you arrived at your answer. Show work. Express how you arrived at your answer for the percent error. And I just showed you guys the green liquid that we're identifying. All right. Density is 0.9 grams per cubic centimeter, or grams per milliliter. That's our density. Okay, this is what we got in the lab. We got 0.9, okay, if we round it. To do percent error, I'm going to do measured minus true divided by true, and then multiply all of that by 100. Okay, the measured value that we got was 0.9, and that's rounding up a little bit. And the actual value, the true value for the density of this liquid is 1. And so that's our true value. It's going to go there. And I'm giving you guys that. The true value for the density of this liquid is 1. It just is. And then 1 on bottom. So 0.9 minus 1 is minus 0.1. Don't know why I needed a calculator for that. Minus 0.1 divided by 1 is still minus 0.1. Then I multiply that by 100, and we get 10% error. And it's minus 10. So we were 10% off. We got 0.9. We should have gotten 1. So our percent error is minus 10%. So go ahead and look at the table and see what you think what that liquid is. Number 6, if oil has a density of 0.88 grams per milliliter, would it float on the liquid used in this lab? So the density of the liquid used in this lab is 1 gram per milliliter. Okay. So if the oil has a density of 0.88, would it sink or would it float? If it's less dense. Okay. Then explain how you got your answer. Use data table number 2 to determine the identity of the metal block used in part 2. So in this question, I want you guys to write what you think the identity of the metal cube was and why you think that, okay? Okay, what am I doing here? What are you doing, sir? Oh, I think I had to go get a napkin. I'm taking that cube out of the water. That's what I'm doing right now. Okay, so there's our cube. So try to figure out what that cube is. Okay. Come on, sir. Keep it moving. Burn in daylight. I think that's it. So make sure you fill out your data table. You'll type in your values. Here's our table. And remember, our density of our block was 8.7. Okay, and that's it, guys. Let me know if you have questions on the lab. I hope this was fun. I'm sorry you guys couldn't do the lab. I talked to the administration. They're not letting us do labs right now because of the situation, but I'm hoping that this is a little bit more interactive. You can see some kind of an experiment where I'm doing something. So I hope this was fun. You guys have a good weekend. Thank you.